want to I want to investigate the solution of a problem that I found on the internet. And it involves circles and triangles, which is what we've been studying. And the the solution that they have to this problem actually uses trigonometry, but we can solve the problem without using trigonometry, just using what we have already learned about circles and triangles. So I want to investigate how we can solve this problem. The statement of the problem here is shown, is given in with the red print right here. In the figure below, the triangle is inscribed inside the circle. The circle has center O. The radius of the circle is 10, this line. And we want to find the lengths of the two sides of the triangle, X and Y, so that the area of the blue shaded region, which is here and a little bit over here, area of the blue shaded region is twice the area of the triangle. So the area of that blue shaded region is twice the area of the triangle. Now, there's several things that we know. We know that that this triangle is actually inscribed in a semicircle because this line right here goes through the center of the circle. So this is the diameter of the circle, making this whole region up in here a semicircle. So our triangle is inscribed in a semicircle, so we can use everything we know about triangles inscribed in semicircles. And we are given information that we need to compute what the area of that semicircle is. The area of the semicircle is the area of the entire circle divided by 2. So that's pi r squared divided by 2. In this case, r is 10, so that's pi 10 squared divided by 2. Or as I have shown here, which is equal to pi times 100 divided by 2. I could further write that as 50 pi, but I'm not going to do it. You'll see why in a moment. Now the area of a triangle, this triangle right in here. What do we know about triangles inscribed in semicircles? We know that every triangle inscribed in a semicircle is a right triangle. Okay? And we know it's a right triangle, and we know with a right triangle, well, we know with any triangle, the formula for area is base times height. With a right triangle, we can take either of these sides to be the base and take the other side to be the height. So the area of this right triangle is 1/2 base times height, or it's x times y divided by 2. So the area of the shaded region, the blue shaded region, is the area of the semicircle minus the area of the triangle. It's the area of this semicircle here minus the area of this triangle right here. That's the area of the shaded region. So that's this right here. This is the area of the shaded region. Now, according to the problem statement, we want the area of the shaded region to be twice the area of the triangle. This is the area of the triangle. So twice xy divided by 2 is just equal to xy. So this is the expression we have for the statement of the problem. Let me simplify that just a little bit. I'm going to do it by adding xy over 2 to both sides of the equation. So I take xy over 2, and I'm going to add it to both sides of the equation. Oh, let me write that a little bit differently than I started out here. So I'm just going to add, on this side, add xy over 2. So when I do that here, what I get is we get 100 pi over 2. When we add this to this right here, that adds up to zeros. So we get 100 pi over 2 is equal to what we have over here, xy over 2 plus xy over 2. That's 3xy over 2. So here's an expression that x and y together must satisfy. Let me take this expression right here and let me solve for y with this expression right here. I solve for y means I multiply both sides of this equation, 100 pi divided by 2. I'm going to multiply both sides by 2 over 3x. So this side over here gets multiplied by 2 over 3x. Okay, these 2's cancel. That 2 cancels with that 2. I'm sorry here. I wrote y. This isn't right. Okay, let me fix that. What this should look like is 2 over 3x times 3xy divided by 2. I don't know what I was thinking a moment ago. Okay, so these 2 cancels. The 3x cancels with this 3x. So what do we get over here? We get 100 pi over 3x equals y. So this is a solving for y in terms of x. That 100 pi over 3x is equal to y. That's one equation relating x and y, but x and y are both unknown. We need if we want to solve for 2 unknowns, we need 2 equations. The second equation comes by knowing the fact that this triangle is a right triangle, and we can apply the Pythagorean theorem. Now, this side, the hypotenuse on this triangle is twice the radius. The hypotenuse is equal to 20. So, applying the Pythagorean theorem here, we get that x squared plus y squared is equal to 20 squared. Okay, 20 squared is 400, in case you don't know. So here's our second equation. So here's one equation for x and y right here. First equation. Here's our second equation for x and y right here. So we solve these 2 equations for x and y. How do we do it? Well, for the value of y that appears here, I'm going to substitute in this expression. Okay, so here's the way that works. Okay, I have x squared. Let me rewrite the equation. I have x squared plus y squared, but instead of y squared, I write 100 pi divided by 3x. So we have this squared, and this is equal to 400. So now wow, this is starting to get where I want it to be, except what's a little bit a problem is I have x squared here, and then here I have a x in the denominator of this fraction, and this is preventing me from solving for x. So I'm going to take both sides of this equation, and I'm going to multiply by 3 divided by 100 pi. No, I'm not going to do that. What I'm going to do is something else. What I'm going to do is I'm going to separate this out, okay? So I'm going to take x squared plus, now I got 100 pi divided by 3 squared times 1 over x squared, and that's equal to 400. Now what I'm going to do, so I'm going to take both sides of this equation, this right here and this right here, that's one side, and this side. I'm going to multiply both sides of the equation by x squared. So if I do that, x squared times x squared gives me x to the 4th. I multiply x squared here, x squared times 100 divided by pi divided by 3. Oh, and I forgot the squared here when I rewrote that. Don't want to do that. This squared times 1 over x squared, and that equals 400 times x squared. Okay, so let me say again what I'm doing. I have this equation right here. Okay, I separate out these two terms. So this would be 100 pi divided by 3 squared, which I forgot a moment ago, times 1 over x squared is equal to 400. Now I multiply both sides of this equation by x squared. X squared times x squared gives me x to the fourth. X squared times this term is exactly what this thing is right here. Okay, so this is x squared times that term, and this is 400 times x squared. Now here, this x squared cancels with this x squared. So I now have this equation. I have x to the fourth plus 100 pi divided by 3 squared is equal to 400x squared. Okay, now I'm going to start another video so I don't run out of my 15-minute limit here on YouTube. So I'm going to start another video and show how we can solve this equation right here. So see you in just a minute.